welcome to this special edition of Naked Neuroscience with me, Hannah Critchlow. This month, we'll be trotting the globe to open our minds. I've been fortunate enough to report on neuroscience from across the world, and this episode will soak up some of the favourite naked brain wanderings, including visiting a banya, a Russian sauna, to be whipped by birch leaves.
It's really cooling and incredibly pleasant. I'm getting nice rushes of air to my face as you're whipping me. I don't know what to say, I'm speechless actually.
All in the name of embracing local culture and demonstrating how the brain regulates temperature. Or so I was told. Plus, from the States, we'll be meeting the caring robot trio designed to help look after our increasingly elderly population, including Brian, who helps people remember to eat.
Hi, my name is Brian. You look very nice today. Please join me for lunch. Today's menu includes some pasta, apple slices, and water.
And Tangy, who encourages people to get together to play memory-boosting games.
Congratulations, you have won bingo. Great job.
Plus, we'll visit a brain bank in New Zealand, keep fruit flies awake in Milan, and back in the UK, we'll meet a rocking professor who's addressing scientific gender inequality through music. All to come. First up, Auckland University, New Zealand contains a bank full of hundreds of frozen human brains, donated by people who have died with brain diseases. This tissue acts as a reference library and research tool for scientists who can analyse the brains and unpick the cause of the disease. Malvinder Singh Bains works with this tissue, but she's been raised a practising Hindu, a religion with strict funeral rituals. After death, Hindu bodies are cremated traditionally near a river, and this cremation is important for the transmigration of the soul from one body to another for reincarnation. Malvinder took me on a tour of the brain bank and discussed how, as a Hindu, she resolves conflicting religious and scientific beliefs.
Okay, and now we're going to go into the Neurological Foundation of New Zealand Human Brain Bank. Long title, but we call it the Human Brain Bank over here. And if you just walk this way, through the music, and we have all our brain bank freezers isolated in rooms.
We've entered into the brain bank room, so it's got a massive freezer in here which is humming away. You might be able to hear it. And there's also a fume cupboard over there where I'm presuming some dissection can take place into very clean conditions. Can you open up the brain bank and show us some of the samples? And the freezer's opening up now, and it's minus 80 degrees centigrade, so it's keeping the brains in a very cold condition to preserve the tissue and all the proteins and the genes that are there.
Absolutely, and we have a few of these freezers. So we have the tissue stored in these columns that are kept in the minus 80 freezer, and they're all designated with a number, and they're all coded specifically. We don't know who these cases belong to for security purposes and also for patient confidentiality. The tissue is kept in these biohazard bags. Just open up one of them. So here we have one tissue block. We've designated it a case of H131. So in this case, I've picked out a normal one. And we've also got the block number on it. So SM4 stands for Sensory Motor Block 4.
So that's sensory motor cortex.
Yes.
So it's a band of your brain which runs kind of from ear to ear. If you imagine having a hairband on or an Alice band, that's roughly about where the sensory motor cortex would be. And the sensory motor cortex is involved in processing all of the sensory information that comes in through our body. So, for example, sense of touch, sense of temperature, and a sense of self as well, I think.
Absolutely. Sensory motor cortex is probably one of the most important cortical regions.
So can we open this sample without jeopardising the integrity of the tissue, but open it and just have a quick look?
Absolutely. So we have each of our blocks that are wrapped in foil. So we snap freeze them using dry ice. I think this one has a few layers on it.
And we're unravelling now the block of human brain tissue.
So this is a fresh piece of tissue, and you can actually see the gyri.
Yeah, so the brain, the human brain, has these folds in it which almost make it look like a walnut. And I can see now all of the gyri, so those like little folds coming into the brain, which almost look like, I don't know, like a riverbed that's flowing into the brain with little bits of blood, which that's how the brain gets its blood kind of supply and the oxygen rushing to it. And I can see that really intricate details there in this frozen block of tissue. It's quite awe-inspiring, actually.
It's very real. You know, when you see the brain this way, you know that this is such a precious gift from a person. And you can even see the little tiny vessels on the top of the meninges. If you look very carefully, you can see the little capillaries.
And that's how the brain gets its oxygen, through this vasculature which lies on almost the surface of the brain.
You can even see the separation between the grey and the white matter. So the grey matter contains all the bodies of the cells of the neurons, and then the white matter contains all their processes. So all of the connections come through the white matter here, and it's just very distinct. We haven't even stained the tissue. You can get so much information just from one block.
It's beautiful. And would you donate your brain for medical research for this type of study?
Absolutely. I think the care that we take into the processing of every single block of tissue and just the brain as a whole, we treat these brains like as if it was our grandparents or our parents, and I would certainly donate my brain with the knowledge of how well we treat the tissue here. With the Indian culture, certain different cultural groups amongst Indians, the Indian population, we have beliefs that the blood of our body is sacred and our organs are sacred, that the tissue is sacred. And this is why when a person passes away, we practice the art of cremating. So in other words, giving everything back to the earth, so sending our ashes into the ocean, and then passing on to the other side. So the sensitive topic of tissue donation, i.e. leaving a part of yourself on earth, is very, very different for Indians. So for me, I've actually had an internal cultural battle as well. I actually wasn't allowed to donate blood at a point.
Because of your family's wishes?
Yes, because of the cultural commitments and also the family understanding there that, you know, blood is sacred. I've brought my parents to the centre and shown them firsthand what we do. And also my parents can see how precious the information is. It's almost as if that knowledge has armed them with the understanding that we can actually learn so much from what we have.
Thanks to Malvinder Singh Baines from Auckland University. Later in the show, we'll be zipping over to Milan to find out about the science of sleep. Have you ever been up all night partying and then crashed out completely the next day? That's your brain's sleep bank getting out of the red to make up your lost sleep credit. We'll discover the sleep brain bank in fruit flies.
Except we don't keep them awake all night partying. It's more sort of a zero dark 30, if you've seen that movie about torture in Iraq. It's more that approach, forced sleep deprivation, like the Secret Service would do.
Poor fruit flies, and they didn't even get the joy of a party to justify their sleep deprivation. But first, whilst reporting on a conference in Russia, I took a little interval to immerse myself in the local culture. The meeting organiser, Andy Irving, took me to the Banya. But what, exactly, is one of those?
It's a place to relax and to experience sauna-like conditions in Russia.
So it's a typical Russian leisure time activity, particularly for those cold, chilly evenings by Lake Baikal in Siberia. And in the Banyan, men and women go into a very hot room that's been heated by burning logs, and it's basically a sauna where, in order to cool down after 10 minutes of heat, men whip each other with birch leaves. And Andy's entering the sauna with some of the birch leaves. Ooh, it is hot in here, isn't it?
It's hot.
And I'm joined by 3 other neuroscientists, and we are actually naked. So we are doing a naked scientist interview. That's nice. And you are?
Mark Cunningham from Newcastle University.
I'm Jamie Ainge from St Andrews University.
And Andy Irving from Dundee University.
Hello. And so what's going on in my head as I enter the sauna? I mean, obviously there's a lot of dopamine being released in the nucleus accumbens as I'm feeling reward and pleasure at the sight of you all here in the Banya. Aside from that, is there anything else that's going on?
There's probably a fair amount of activity in your amygdala at the abject fear that's also going on at the same time, but there'll be some processes going on. So we know, for example, if you increase temperatures in the brain, then you affect some fairly fundamental physiological mechanisms. So things like the oscillations in your brain will vary quite dramatically depending on the temperatures.
So there's nerve endings on my skin, and they're sending lots of electrical signals up to my brain, to a region of the brain that are regulating temperature and sensing the temperature, and that is causing different electrical activity oscillations?
Yeah. Well, thankfully it isn't happening right now, given that the body spends a lot of time basically making sure that our brain stays at a relatively constant temperature. So if we stayed in here for a long time and we have a little timer on the wall to tell us when we need to get out, then we might start to see these sort of fundamental mechanisms changing, as I say, quite dramatically, and that would be fairly bad. So if we could sort of record brain activity at the moment, that might be one way to tell each other when we should be getting out of here. As I say, Mark knows more about this than me.
So at the minute, the temperature in the Banya is close to 70 degrees centigrade, which is obviously very far away from what we're used to at room temperature. And so one of the things that our brain will try to do is it will obviously try to kick in with feedback mechanisms to maintain a form of homeostatic balance. And one way that it does this is through thermoregulation. One of the most obvious examples of thermoregulation is the fact that we are now perspiring quite a lot, again to try and sort of control the core temperature.
I'm glowing, not perspiring, and definitely not sweating.
You are glowing, and I am sweating. I'm a sweating neuroscientist, and I mean, as Jamie already alluded to, large groups of brain cells within the cortex, within the brain, are capable of generating coherent synchronous activity in the form of brainwaves. And those brainwaves have been previously demonstrated in an experimental study to be very much temperature sensitive. So if you experimentally in a controlled environment change the temperature in which very thin sections of brain are maintained from which you're recording these brainwaves, you can see changes in the dynamics of this activity. So ultimately, if you push that temperature too far, you can, in some cases, particularly in children, elicit seizures, and this is very well documented in the case of febrile seizures, where young kids who are still, their brains are still trying to learn in terms of the adaptation processes with regard to thermoregulation. If their temperature rises due to a fever, out of physiological ranges, it can actually elicit a febrile seizure.
So a seizure is like a kind of epileptic fit, kind of like on the floor, shaking uncontrollably.
Yes. And so there is good evidence that our brains are very sensitive to temperature, and if we are not able to control that, then pathological or dysfunctional activity can arise.
And Andy, I believe you have wrestling there in your hands. One way that we could make sure that we don't increase the temperature too much, so to help us cool down, what's this? Well,
what I'm holding are birch leaves. So these are traditional Russian method and approach to actually shake and administer little droplets of water so that you can cool down while you're in the banya. And also these are gently used to promote blood flow to the skin while you're in the banya, which is an important aspect of the entire process. And I think that the increased blood flow is actually very good for the brain because by increasing the oxygen supply, particularly to the prefrontal cortex, that will allow us to experience the entire banya in a much greater and more memorable fashion. So if we continue to...
It's really cooling and incredibly pleasant. I'm getting nice rushes of air to my face as you're whipping me. I don't know what to say, I'm speechless actually.
All in the name of getting in touch with local tradition and demonstrating how our body and brains regulate temperature. Or so I was told. Thanks to Andy Irving from Dundee University, Mark Cunningham from Newcastle and Jamie Ainge from St Andrews for that lovely relax on the edge of Lake Baikal in Siberia. Next, whilst in Milan for the Federation of European Neuroscience Societies meeting, I caught up with Professor Gero Meisenbock to find out what he's discovered from sleepless fruit flies.
So flies actually sleep more than we do. they're quite lazy. They spend about 16 hours a day asleep. And their sleep is usually concentrated during the night. They are day active, but they also take a very long siesta in the afternoon. If you take away sleep, if you keep a fly forcefully awake, it sleeps more during the following day. So it has to make up for that sleep deficit. It's widely thought that we have two control mechanisms in our brains that regulate sleep. One is the body clock, which will be familiar to many of you. And the other one is this strange device that senses whether you've got enough sleep or not. And that then determines that if you haven't got enough sleep, it puts you to sleep.
And so the body clock in the brain, for example, is this little kind of cluster of nerve cells about the size of a pinhead that will regulate when you fall asleep and when you're awake. And then there's also, you're saying, a second system called the sleep homeostat, which can cause you to compensate for lack of sleep. If I haven't slept very well last night, for example, hopefully I'll be able to get a lie in tomorrow.
Exactly. You're probably normally not aware that there's two mechanisms that influence your sleep and waking, because normally these two mechanisms operate in sync. So when your body clock says it's nighttime and you should go to sleep, your sleep homeostat also says you've been awake all day, so please go to sleep now. But as you know, there are certain situations where you can dissociate the two things and they start fighting against each other. One such situation is if you've pulled an all-nighter, either for work or because you were partying, and then you will have no trouble usually going to sleep in the morning, even though your body clock will tell you to stay awake. There's also another frequently experienced situation which happens after intercontinental travel. I, for example, then suffer these extremely painful situations where my sleep homeostat screams with fatigue, but I still can't go to sleep because the body clock keeps me awake. Every animal needs to sleep. It will die without sleep. But nobody really knows what sleep is for. There's various ideas around, but nobody's really gotten to the heart of the problem. I don't think that by studying the circadian clock, you will. I view the circadian clock as an adaptive mechanism that makes sure that you do your essential sleeping at times when it hurts you least. I mean, taking your brain offline is obviously a risky thing to do. You're more vulnerable, and you also have a cost of lost opportunity because you could be working or giving interviews. But if you time these inactivities so that they interfere least with your lifestyle, then that's an advantage.
And so the region of the brain that's involved in this sleep homeostat is almost like a bank account, which measures whether you've got credit or deficit in terms of this sleep and whether you need to compensate and make up for it.
The bank account is a very, very good analogy. The one that I use often is the thermostat on your living room wall. So the thermostat measures temperature and switches on the heating if it's too cold. The sleep homeostat measures waking time and puts you to sleep if you've been awake for too long.
And so you're investigating this in the fruit fly. So are you keeping the fruit flies up partying all night so they're massively in the red, and then trying to figure out how their brain senses that they need to put some sleep credit into their bank account?
That's exactly what we do. Except we don't keep them awake all night partying. It's more sort of forced sleep deprivation like the Secret Service would do. What we have is we have our flies in sleep monitors and we rattle them all night. And we found mutant flies that cannot put in these extra few hours of sleep. So in them, the sleep homeostat is broken. And as a result of this chronic sleep deprivation, they have severe cognitive impairments. Now, how do you measure a cognitive impairment in a fly? You test its ability to learn and remember. Like humans, if you sleep-deprive flies, they don't remember their lessons well. So cramming before an exam is never a good idea.
And there's many mental illnesses that are associated with sleep disruption. So, for example, Alzheimer's, dementia, even depression. And so it's really crucial that we try to understand this bank of sleep that we have in our brains. How on earth are you measuring this in this minuscule fruit fly brain whilst you're rattling and keeping them awake?
So we measure sleep by putting individual animals into glass tubes. And these glass tubes get bisected by an infrared light beam. And whenever the fly walks up and down the tube, it crosses the light beam every few seconds or so, and we simply count how many beam breaks occur. And sleep in flies is defined as any pause where there's no beam breaks for at least 5 minutes. The project that we did started with a postdoc looking for flies that had neurons in their brain that could be activated artificially. And he found that when he activated a specific small group of neurons, just about 12 cells in each hemisphere of the brain out of the 100,000 or so cells, the flies would nod off. They would go to sleep. And then he looked at some of the genes that were active in these neurons, and he found one that, when it was mutant, rendered the flies insomniac and also unable to compensate for a sleep deficit. And at that stage, a second postdoc joined the project, and he had the fabulous technical skill of being able to insert a tiny, tiny, tiny glass tube into the brain of these flies and actually measure the electrical currents from these neurons. What he discovered was that in the mutant flies, these neurons were electrically silent. So if you can't switch these cells on, you're sleepless.
And that's exactly how the human brain works as well, isn't it? We use this electrical activity in order to switch on particular areas of the brain. So the same kind of thing is going on in this fruit fly to switch on sleep using a very discrete 12 nerve cells within their brain.
Yes, brains are devices that run on electricity. All information in the brain is encoded in the form of electrical impulses. So streams of electrical impulses represent what we see. A stream of electrical impulses are emitted by your ear as you listen to this podcast and are then interpreted by other structures in the brain. Streams of electrical impulses are fired in my brain now, hopefully, as I'm trying to make sense and explain what's going on. And also streams of electrical impulses control the movements of the muscles that are important for me to produce the speech. What was surprising was that there's also dedicated cells whose streams of electrical impulses encode the need to sleep.
And there's particular genes within these fruit flies that render those particular nerve cells sensitive to electrical impulse. And if you don't have the right version of those genes, then you can't get to sleep.
That's correct, yes.
And so does a similar thing happen in humans that suffer from insomnia?
So there's a homologous structure of nerve cells in the human brain. These are also neurons that are electrically active while we sleep. These neurons, like those of the fly that we have studied, are the targets of general anesthetics. So general anesthetics activate these cells and it puts you to sleep.
And so have you basically found the bank of sleep that can figure out whether you're in credit or debit for sleep?
I think we have found an element of the bank. We don't know whether it's the actual area where the account is kept. What we know is that what these neurons do is that they convey the message that you are in debit and that you need to go to sleep. How credit and debit get accounted is one of the pressing questions for future research. We'd love to be able to discover what actually is monitored in the brain to determine how high or how low your sleep balance is.
Thanks to Gero Meisenbock, Professor of Neurocircuits at Oxford University. Next, with my sleep bank firmly in the red from all of this jet setting, we go stateside. There's a growing elderly population across the world whose cognitive abilities are declining. So could robots help jog memories and support these people in their daily activities, whilst also keeping them socially active? To find out more, I met Professor Goldy Nijat, who spoke at the International Neuroethics Society annual meeting in Washington, America, on how robots can help the elderly.
The idea is that we're trying to design socially assistive robots that can help the elderly. Robot can engage people in recreational activities, memory games, as well as help them with activities of daily living that they may find difficult to do on their own.
And these are 3D walking, talking robots that can also emotionally and socially engage with the elderly.
Right, so the idea is to have natural communication between a robot and a person. So just like we display expressions through our face and body and through what we say, the robots do exactly the same thing, and they're embodied in their environment so that, you know, they have a better engagement tool with people, so the person can be engaged looking at a physical 3D robot in front of them.
Do they look a little bit like a person or more like a robot? Are you almost tricking the elderly elderly into thinking that they're interacting with a person?
So they all look very robotic. So you can actually see the metal, the wires, the plastic, and that's done on purpose. And even with the Brian robot, for example, when it moves its arms, you can hear the motors, there's noise. And that's all done because we want to make sure that people understand these are robots that they're interacting with. We're not trying to fool them into thinking that these are people.
And we're now going to hear a little sample of the type of prompting and encouragement that the robot Brian can give whilst trying to help the elderly remember to eat when they've got Alzheimer's.
That's a good helping of food you have there. Please take a bite.
So Brian prompts a person through the steps of eating by encouraging them to, for example, pick up their utensil, bring the food to their mouth, tells jokes during that time. And the idea is that, during the interaction, the robot is happy when the person's doing it. It displays facial expressions, happy, big smile, excited voice, and gestures, body language, like it gets excited, does a little dance when the person eats properly. And at the same extent, we also do a few different expressions where the robot will get sad if a person gets disengaged in eating. So if they get distracted and look away, the robot tries to re-engage them by getting sad that they're not interacting with it anymore. And so kind of that's the idea of how we display expressions too. When a person's interacting with us, the robot uses that to keep a person engaged in eating.
Some people with Alzheimer's might not remember how to make a meal, and so you've developed Casper to help with that.
Yes, so Casper, the idea is that when it's mealtime, for example, Casper can go find a person, bring them to the kitchen, and really prompt them through the steps and make it a fun activity, recipe finding what they want to make, and then go through the steps and show videos of how to exactly make the food, and then so that the person will enjoy eating the food after, and they have some, encouragement to do so.
And then Tangi is a robot that assists with playing bingo.
Yeah, so Tangi is a group robot. So the idea is that it facilitates, a few people, 5 to 10 individuals playing a bingo game, and the robot provides encouragement, calls out the bingo numbers, help if, someone forgot to mark, for example, a bingo number.
B12 was previously called. Please mark this number on your card. Wow, you are getting close to having bingo.
And then again celebrates with a person when they win bingo.
And how do the elderly react to these robots? I mean, we're talking about a generation that weren't brought up with computers. So how do they react? Do they really engage with the robot?
The robot engagement or interaction with a person is very natural. The person doesn't have to learn how to use the robot, for example, right? It's pretty much the same way we interact with a person, another person. So the idea here is that the robot is engaging and displays expressions and behaviors similar to how we do. So that learning curve is gone. So this whole idea of using technology that you've never used before, the ease of use of the robot promotes its acceptance.
One part of the reason for studying this is it to try and replace carers, human social interaction, humans that would normally help and support these activities for the elderly. And is that ethical?
That's a very good question. So robots are being designed, in our case, to help the healthcare professionals. So we do actually, a lot of our interactions is with the healthcare professionals themselves to find out what their needs and wants are. And really we're trying to design robots as assistants or tools that they can use so they can focus their attention on, high level tasks that they need to do and only they can do, and the robot can supplement them. A lot of the jobs, there's a lot of turnover rates because, people go in, they're very overwhelmed and they leave the job. So the idea is that we help use the robots to minimize stress and the workload that they have, especially since we have this growing population of elderly people, right? And we need to take care of them, find a way. So we want to assist both the elderly individuals, right, to benefit, but as well as the healthcare professionals in, helping them do some of this repetitive tasks that the robot could take over for them.
And at the moment, how much would Casper cost?
So I should mention they're all kind of at the research and development stage. So the good thing about our robots is that we're trying to use off-the-shelf components, right? So a lot of the sensors can just be easily purchased and integrated. So we've kept the costs down in designing and developing these robots. So to build something like Casper or Brian has cost us maybe $5,000 to $10,000 to do. And the idea is that, as mass production happens of these robots, we can keep the costs affordable so that people can buy them.
Professor Goldie Nejat from Toronto University. Well, zipping back home, imagine, if you will, that you're a male psychology professor at Cambridge University and the love of your life your wife Lisa, is also a scientist. Together you run a lab and you see firsthand the sexism in science. Oh, and also imagine that in addition to being a professor, you're pretty musical, supporting the Red Hot Chili Peppers on tour. So, what do you do to fight gender inequality? Well, release a single on the subject, of course. I've spoke to Tim Bussey, the professor and also rock star, behind this re-release hit from the 80s.
I'm in a band called Violet Transmissions, and we've recorded a version of Thomas Dolby's song, She Blinded Me with Science, for women in science, specifically to raise awareness and celebrate women in science.
And what inspired you to actually initiate this project in the first place?
In my own lab, which I've had now for, I think it's 14 years, some of the very best scientists that have come through this lab have been women. And given that my experiences, it surprises me when I look around me at my colleagues, I sit on a committee, I get invited to be in a symposium where the majority of participants are still men.
So to you, there seems to be a gender inequality, a sexism within science. And so this video is really to try and promote the role of females, successful females within science.
Yeah, I mean, that's right.
And can you tell us a little bit about the song?
The song is, well, it's by Thomas Dolby. It's from the 80s. You know, it's been exciting for me working with him to some extent because he was a bit of a hero. I think he was a groundbreaker in electronic music. That song went to #1 in many countries, and for a while you couldn't get away from it.
And Thomas Dolby's chorus includes She Blinded Me with Science. So how does that reflect with Lisa, your wife? Did she blind you with her scientific prowess? Is that how you got together?
We did meet in a scientific context. We were both actually at UBC in Vancouver, in Canada. So I was an undergraduate and she was a graduate student at the time. But really, it grabbed me simply because I love the song in the first instance and because that hooky chorus line is absolutely perfect for what we wanted.
And you also got Orphan Black, so that's a BBC broadcast programme involved in the project, I believe.
That's right. Now, Orphan Black is a fantastic example of a show that features women scientists in important roles. What impresses me about it is that it's all very matter-of-fact. It's not a big deal in that show that the scientists are women. It just seems very, very natural. It's very impressive, and so I'm really pleased to have them involved. Some of the clips from the show with the woman scientist characters are in the video.
And you filmed the music video in quite a special location, I believe.
Yeah, that's right. Newnham College, they let us film in the old labs, and that was a lab where women scientists could do their science before women were allowed into Cambridge University. So it was a perfect place to film the thing. It was quite a good set too, so as a bonus.
Tim Bussey from Cambridge University. You can find out more by visiting World Wide Web sheblindedmewithscience.org, and all proceeds from the song go to Science Girl, an organisation dedicated to celebrating and supporting women in science. Well, that's all we have time for this month, I'm afraid. I hope you've enjoyed this special episode, globe-trotting to take in the wanderings of a naked mind. Thanks to all those that took part: Malvinder Singh Baines, Goldie Nugent, Gary Meisenbach, Andy Irving, Mark Cunningham, Jamie Ainge and Tim Bussey. I'm Hannah Critchlow, this is Naked Neuroscience, and until next year, well, we'll continue our journey to open our minds, reporting with the President of India on the opening of a special neuroscience institute in Calcutta. Bye-bye.